Good morning or good afternoon. We are on 7.01. We're going to start a new unit on polygons today. So this is a little bit of an intro, basic shapes, basic polygons, the names, and then also about their angles. So first, let's just go over the names of some polygons. So if a polygon has three, actually, you know what, let's first start off with what a polygon is. So a polygon is a plane shape, meaning it's a two-dimensional shape. It has to be a closed figure, and that's with straight sides, meaning it can't have any curved sides. Now let's talk about their names. So we'll just set up here. We'll go 3, 4, 5, 6, 7, 8, 9, 10. We usually don't do 11. It's not that common. And then 12. So take a moment here, pause the video, and see if you could write down the name of each of these polygons with that number of sides. So for example, three-sided polygon is a triangle. So take a moment and see if you can fill in the rest of these. All right, so hopefully you came up with quadrilateral. If you said square or rectangle, that is too specific. A quadrilateral is one that has just any polygon with 4 sides. 5 sides is a pentagon. 6 is a hexagon. 7 is a heptagon, and that's probably the most common one for students to miss because they call it a septagon, but it's a heptagon. And then 8 is an octagon, which most of you probably, hopefully know. 9 is a nonagon. 10 is a decagon. And 12 is a dodecagon. And if you're curious about 11, that's an undecagon. All right, so those are just the names. You do need to know all of these polygon names because sometimes they use them in the problem and they're assumed that you know how many sides each of those figures has. All right, so now let's talk more specifically if you have a regular polygon, which comes up quite frequently. And you guys should have seen this in the younger grades as well. A regular polygon means it's a polygon with all sides are congruent and all angles are congruent. All sides and angles are congruent, are equal. And then we're going to go over some formulas. So a very, very important formula is the sum of the interior angles of an n-sided polygon. Okay, so this is the sum of the interior angles. And to find that, you're going to take however many sides it has and subtract that from 2 and multiply that by 180 degrees. So really what you're doing when you find the sum of the interior angles is you're looking for how many triangles you can actually make from that polygon and multiplying it by 180, which you can always make 2 less than the number of sides. Now, if you wanted to find the measure of each, so just a single interior angle, and this would only work if it was a regular polygon. So the measure of each interior angle of a regular polygon, because if it's not regular, then all the angles aren't the same. So we wouldn't be able to find it this way, of a regular polygon that has n sides. So to do that, you would take the sum of the angles in your polygon and divide it by how many angles you actually have, which should be the same as the number of sides. All right. And next we'll talk about the sum of the exterior angles of an n-sided polygon. And this one sometimes throws students off because it's always the same. It's always going to be 360 degrees. So no calculations there, just 360 degrees. And then lastly, the measure of each, so a single exterior angle. And again, this one would have to be a regular, so they're all the same. All angles are the same, regular n-sided polygon. And just like with your interior angles, you would take the sum of all of the exterior angles and divide it by how many sides you have. So these are all formulas that you need to have memorized. So some of the interior angles, some of the exterior angles, and then how to find one of each of those angles as well. Before we do some problems with those, I do want to talk about the difference between convex versus concave figures. So a polygon is convex if when you extend one side, or extend any side, it contains no point in the interior of the figure. So for example, here, if you extend any side, it doesn't cut through the figure. That tells you it's going to be convex. A polygon is considered concave, so not convex, if at least one side, so only it has to be one of them, when extended, cuts through the interior. Of that shape. For example, something like this. So if I were to extend one of these sides like here, it actually cuts through right here the inside of that figure. All right, now let's start to get into some examples. So let's start with number 1. Find the sum of the interior angles of a nonagon. Okay, so we're really just using our formulas here. And this is where, like I was saying before, it's important that you know the names of the shapes. So you need to know that a nonagon has 9 sides. We also need to know our formula for the sum of the interior angles. So I know my formula is 180 times n minus 2. I know now I have 9 sides. So I would just substitute in 9 in for n, since n is the number of sides. So 180 times 7, which gives me 1,260. So there would be 1,260 degrees in all of the angles combined. Next, find the sum of the interior angles of a regular dodecagon. Okay, pause here and do this one on your own. So you should have found that you had 12 sides, and then we would do, again, some of the interior angles. It doesn't actually matter at this point that it is a regular dodecagon. It just matters that it's a dodecagon. So that gives us 1,800 degrees in the sum of the angles. Now, second part, I want you, so let's say that was A. Let's call this part B. Now I want you to find the measure of each interior angle, so a single interior angle. Now here's where it's really important that it was a regular figure. So we know now the sum of all the angles is 1800 degrees, and I know that it has 12 sides, so 12 equal angles. So I want to take 1800 and divide it into 12 equal parts. And you can type that right into your... All right. Next, number 3. Find the sum of the exterior angles of a heptagon. Using your formulas, pause the video and see if you can do this. All right, so first of all, heptagon has 7 sides, but it doesn't really matter because all of the polygons have a sum of their exterior angles at 360 degrees. Actually, let's do part B for that one. So that's A, B. Now, if it is regular, meaning all sides, all angles are the same, find the measure of one exterior angle. Go ahead and try that now. All right, so now it does matter that it's 7 sides. We're going to take the sum of the exterior angles and divide it by 7. Now, this does not give us a nice answer, so we'll just write out our decimal. Or you can just leave it as 360 divided by 7 degrees, which would be as reduced as you could go. So that would be your exact value. And then this would be your decimal version, which is rounded. All right, number 4. Find the sum of the interior angles of a 38gon. So when we get up to the higher ones, we can just call them with their how many sides they have, gon. So a 38gon means it has 38 sides. So pause the video and find that right now. All right, so you should have subbed 38 in for n, and you should have gotten 6,480 degrees. Next, find the value of x. So these I'm going to need to draw out for you. You'll have to copy down. So there's a couple. Let's do A. So these will not obviously be drawn to scale, but all of these lines we're assuming are straight lines, not curved. So here's 72 degrees, 136, 127 degrees, 108, and we'll call that x. I want you to find the value of x. So pause the video and try to think through how you might be able to do this and do it. All right, so hopefully you said, okay, well, let me count how many sides this has. 1, 2, 3, 4, 5. So this is a pentagon. And we want to find x. So in order to find x, I need to know how many degrees are in the entire figure. So to do that, I'm going to add up all of these angles together. So 72 plus 136 plus 127 plus 108. Now, if I add x onto that, that should give me the sum of all the angles in my pentagon. Well, wait a minute, I don't know the sum of the angles in a pentagon, so how can I find it? So to find it, we want to use our sum of all the angles formula. So I'll take 180 times n minus 2, so that's 5 minus 2, or 180 times 3, which gives me 540 degrees. So I set all of that equal to 540 degrees. Now, this part, you're just going to type right into your calculator. I do need to see at least this. So some students try to just like give me the answer on these questions without showing work. And if you just typed in a little number wrong or made a small mistake, you lose full credit if you don't show any work. So you need to at least show me that 443 plus x equals 540. So at least I know if that's where you went wrong. And now just subtract your 443 over. And we get x equals 97 degrees. Okay, let's do 1, 3. Okay, so this is 1, 2, 3, 4, 5, 6, 7, 8. So we have an octagon here. Again, not drawn to scale. And I'm going to give you that all of these sides are congruent and all of these angles are congruent. And I want you to find x, which would be the measure of this angle right here. Pause the video, go ahead and try that. All right, so hopefully you said same as before. We need to find the sum of all the angles first. So I'm going to take 180 times, I have 8 sides, minus 2 is 6. So it gives me 1080 degrees. Now I want to find just one of those angles, but from my markings, I know this is a regular polygon because all the sides and angles are the same. So I take the sum of all my angles and divide it by how many angles I actually have. And that leaves me with 135 degrees in each of those angles. So x equals 135 degrees. Okay, that was number 5. Number 6. The sum of all the interior angles of a regular polygon is 3,960 degrees. How many sides does the polygon have? All right, so for this one, they are giving us the sum is 3,960 degrees. So let's start then, that's all the information we have, and we want to know how many sides. So let's start with our sum formula then. So we know the sum is equal to 180 times n minus 2. So that's good. We have an n here, so we need to solve for n. So let's substitute in what we know. Well, we know the sum is 3,960. So we're going to put that in for the sum. So set this equal to 3,960. And now we're going to solve for n. And there's a couple different ways you could solve for n. You could start by dividing by 180, or you could start by distributing. I'll let you guys decide which way you'd prefer. Pause the video and solve for n. All right, so I'm just going to divide by 180 on both sides. Again, you did not have to do it this way. And I get 22 equals n minus 2. Add my 2 over, which tells me this polygon has 24 sides. Next one. The measure of each interior angle of a regular polygon is 150 degrees. How many sides does the polygon have? All right. So there are a couple different ways, and we'll talk about two different ways that you could solve this. So first, let's do it like the last one we did. So we're starting by giving the measure of each interior angle. So we know it's regular, so they're all going to be the same. So I could start off with my formula. So 180 times n minus 2. So the sum of all the angles divided by how many angles there are, that's equal to the measure of each individual angle. Now I know each angle is 150 degrees. So then I could substitute that in for the measure of each angle. And now I just need to solve for n. Now I do have two n's here, so this one will be a little bit more challenging. But one way to start this is you could put 150 over 1 and then cross multiply. So go ahead and give this one a try, pause the video, solve it on your own. All right, so if I cross multiply, I get 150n equals 180 times n minus 2 times 1, so nothing changes there. Now I'm going to distribute my 180, so I get 180n minus 360. And combine my like terms, so I'll subtract over the 180n to get negative 30n equals negative 360. Divide both sides by negative 30. Computer's starting to act up. And the number of sides would be 12. Now here's another way that's a little bit shorter of how you could do it. You could also have said, all right, well, if I know each interior angle is 150, I know that when I have a polygon, I'll show you a triangle just to give you a visual here. If I know one of these interior angles, then the exterior angle is right next to it. They're going to form a linear pair. So the exterior angles of a polygon are these ones out here. So, and we know those are all the same if it's a regular polygon. So what I could do is if I know one of these angles right here, then I could subtract that from 180 to find the exterior angle that's right next to it. So I could take 180 minus 150, and that gives me 30 degrees. So now I know that's the measure of each exterior angle. I want to know how many sides it has. So now if I know that the sum of the exterior angles is always 360 degrees, and each of those angles is going to be 30 degrees, I can take 360 divided by 30, and that would give me 12 sides. So a little bit shorter, but a little bit more understanding and having to apply the exterior angle formula. But either one of those would be acceptable. Okay, number 8. Okay, so I'm just going to give you guys a couple to do completely on your own. So the measure of each exterior angle of a regular polygon is 24 degrees. Find the number of sides. Okay, so what I'm looking for in your notes is that you're going to show the work and check the answer. So go ahead, pause this, show the work out, find the number of sides. So you should have gotten n equals 15 for this one. So there's 15 sides. On your notes, I'm looking for that you guys have all the work shown to get that. Number 9, we'll do one more. The measure of an interior angle of a regular polygon is 157, 0.5 degrees. That's 157.5 degrees. I would like you to find I want you to find the number of sides, so find n. Find the sum of the interior angles. And find the sum of the exterior angles. And one exterior angle. Pause the video, go ahead and find that. Make sure you show all work. Right, so n should equal 16. Again, you should have work to support that. The sum of this is a symbol for sum, it's a summation. The sum of the interior angles is 2,520. Sum of your exterior angles, hopefully it was a quick question, is just 360. And one exterior angle should be 22.5. Again, I'm looking for on your notes that you do not have just what I wrote right here, but you have all the work to support that. Right? And that is it for your notes today. Again, if you have any questions, make sure you let me know. And pie out.